ACES is a national centre which brings together individuals from various partner organisations around the country, and our focus is in the area of electromaterials science. We work very effectively in an integrated way, bringing together the best minds from around the country to tackle those critical challenges. We're particularly interested in how nanoscience applies to electromaterials, these materials that conduct charge, transport and transfer charge. We can tune both the physical and biological properties to create better energy devices and better devices for medical bionics.
What we do here is develop functionalisation of these nanostructured electromaterials. It's really critical that we're able to create materials which we can control on the nano scale and create devices which are far more efficient than any of the kinds of devices that people now make on the macro scale. We've built up a huge expertise here in what you might call reactive fabrication, where you can start to use printers, additive fabrication facilities to now print at the nano dimension or the nano scale, start to take functionalised materials and put them together in an ordered fashion with the control that we will have with the functionality we put on the materials. That allows a lot more order in the materials and allow us to create much better materials for the sorts of things we're doing in energy and bionics.
Nanoscience allows us to develop structures at a nano-dimensional level, and these allow us to create very efficient energy generating devices and energy storage devices like batteries. What we're talking about in terms of water splitting is a relatively simple chemical reaction which makes hydrogen from water as a fuel. The big challenge in water splitting is to make electrode materials that are very efficient in this water splitting process. We've recently formed a small spin-out company called Aquahydrix. We see this as a mechanism for simply supplying hydrogen to industries that currently use hydrogen. In the bigger, longer-term picture, we see this as an alternative fuel source, and that will create whole new industries and whole new supply chains of energy based on hydrogen.
The Centre of Excellence for Electromaterials Science is using the idea of nanostructuring of materials such as electrodes, electrolytes and interfaces between the electrode and electrolyte to develop new energy storage materials such as lithium-ion batteries, magnesium-air batteries and zinc-air batteries. In terms of bionics, we need energy storage to be able to drive some of the processes that we want to drive in the body. For example, if you want to grow nerves on demand in the body, you need to apply potential. You need the battery to drive that process.
Nanomaterials enable the creation of higher resolution factors within the devices that we create. This allows for better control of biological systems through the provision of higher density electrode systems that deliver much more electrical energy to biological systems. ACES Bionics research has utilised nanomaterials in the formation of structures that provide very highly controlled guided growth of nerve and other tissue systems, whilst also creating electrode structures with much better capacity to deliver electrical stimulation to biological tissues. ACES developments will contribute to a global revolution in the health industry, particularly in the manufacture, design and improvement of devices that improve human health.
As nanoscience touches every part of our lives, its ethical implications can also shape everything. The ethics program is closely linked with the bionics program here at ACES, and within that we do a lot of work on how developments in nanoscience, in electromaterials and in bionics can affect society and the ways in which social attitudes can shape the way we understand and respond to those developments. We do things like have community engagement programs where we bring cross-sections of the community, cross-sections of the regulatory bodies, researchers and those who work with in clinical practice, for example, together to talk about the ways in which developments in nanoscience affect the community and to find out what people think about that.
We've built up a collaborative network around the world over the last 20 years or so. ACES hosts an annual symposium which brings together experts from around the world, and the whole purpose of the symposium is to consolidate existing national and global collaborations and to identify and build on new opportunities for collaboration.
When we can all come together, we can learn from each other and in the end make much better research.
This is extremely important because it's good to collaborate with people and get feedback of people with even results and data and even new ideas.
If you want to get a connection, a link between different universities and different groups, this is the right place to be.
We are sitting at a very exciting place in the research of nanoscience at the moment. As we can separate and process individual nanocomponents, we've uncovered extraordinary properties within those nanocomponents. But now our challenge is to take those nano building blocks and to assemble them in 3 dimensions with control over where they are distributed and realise real practical devices in energy or in medical bionics that can have immediate application. We do appreciate that the challenges that we're faced with are big global challenges, and we think that we need to build big global multidisciplinary teams, pulling together the best people in the world if we're going to deliver practical outcomes to those challenges in the shortest period of time possible.